Okay, in this question we have a fish tank and a fish inside the fish tank. So here is our fish tank and here is our fish. And the light from inside the fish tank, so here's the water on top of the fish tank, the light hits the side of the fish tank, which is, so that's the normal, at an angle of approximately, the light's traveling in this direction, approximately 35 degrees. So this is 35 degrees. Okay, question, what angle does the light come out of the fish tank at? Well, what we have to realize here is that this is water and this is air. So index of refraction for air is 1.003, and for water, the index of refraction actually for the glass is 1.5. Now this isn't really glass, it's more like plastic. But in any case, there is a thickness to it. So maybe I should draw it like that. Now, the question says basically a thick sheet of plastic where the index of refraction is equal to n for the plastic, 1.5, the side of an aquarium. The light reflected from a fish in the water has an angle of incidence of 35 degrees. But what angle does the light enter the air? So if I blow this up, if I kind of make it thicker, this region that is, what we've got is, here is the plastic, here is the air, and here is the water. Okay? The plastic's index of refraction is 1.5. The air's index of refraction is equal to 1.0003, and the index of refraction of water, I believe, is 1.33. Now I can just double check that, but I think it's 1.33 for water. Yes, that's right. So the index of refraction for water is 1.33. So what happens? Well, we know that the incoming ray is actually hitting the side of the plastic at 35 degrees. So that means here's my normal, and that is 35 degrees. Okay. Well, what angle does it leave this at? Well, what we have to kind of understand here is what situation do we have across this boundary here? Which one is faster, water or plastic? Well, water has the smaller index of refraction, plastic has the higher one, therefore plastic is slower. Okay? That means the water is faster. So that means we're going to go FSTN since we're going in this direction. FSTN is towards the normal, therefore we're going to bend a little bit that way. So what's this new angle here? Well, in order to figure that out, we can use Snell's law. So we'll go Ni sine theta I equals Nr sine theta R. And we're looking for theta R. Therefore, theta R is going to equal the inverse sine of Ni sine theta I all over Nr. Now, in this case, that's going to equal Ni in this case is 1.33. That's water. Sine 35 divided by Nr, and the refracted one is now plastic, and so that's 1.5. Now this is going to give us, let me just do that calculation here, 1.33 enter 35 sine times 1.5 divided by and inverse sine. So we've got 30.6 degrees. Uh, 30.5, let's just say 5.7. Okay. So now that we know that, question, what's the new incident angle on going from this boundary, so from this side of the plastic? Well, if you notice now that we know that this angle is 30, well, what's the new normal going to be over here? So if I draw a normal line there, now in order to do this, you need to know a little bit of algebra, or sorry, not algebra, geometry. So if I drew this a little bit bigger, and I said, all right, well look, here is the plastic of the aquarium, and we know now that if I drew a normal here, we know now that this angle is, let's say, 30.1. Then if I drew another parallel line to this one, right? This is a parallel line. This is a parallel line, this is a parallel line, so they're parallel to each other. Therefore, this angle is 30.1, and using geometry concept of alternate interior, that would also be 30.1, okay? And guess what? That is our new angle of incidence. However, now we know that this is 1.5 index of refraction and this is air 1.003. Therefore, we're now going from slow to fast, and this is a superfan situation. And superfan is away from the normal. So, bending away from the normal, that means it's going to bend that way. Okay? So, what's this angle here? Well, it's pretty much the same equation as this one, except now we've got different values in for it. So we're still looking for theta r, but now yeah, so well, let's just continue here. Yeah, so it's 30.57 degrees. Yeah, I know. I've just rounded to 30.1. Oh, I'm sorry. I made a boo-boo. Thanks for catching that. 30.57 does not round to 30.1. It rounds to 31. So this should have been 31, and this should have been 31. Thank you. So let's try and speed this up now. So basically, I've got the angle, the index of refraction from incidence is 1.5 now, because that's where we're going from. And the angle in which we're hitting that is approximately 30.5, or let's just use the exact value here, 30.57. And the new one, the new index of refraction which we're going into, which is air, is 1.003. So let's take the sine of this, and let's go 1.5 times, and let's go 1.0003 divided by, and take the inverse sine of that, and we've got an answer of 49.7 degrees. So in fact, that is our final answer. So that's that's this angle here. And that's the angle by which the light enters the air. And that's the end of this question.